Imagine the year 2100. Does your vision of the future include receding shorelines? Since humans started burning carbon for energy, CO2 molecules have accumulated in the atmosphere, producing a world with increasing global temperatures and rising sea level. CO2 in the atmosphere insulates the Earth through a process called the greenhouse effect. Some of the incoming solar radiation is reflected off the surface of the Earth, but most of that solar energy is trapped in the Earth's atmosphere by molecules such as CO2 and other greenhouse gases. Greenhouse gases are crucial because they keep the surface of the Earth warm enough for life to survive. However, human activities are now producing greenhouse gases at an unprecedented rate. The addition of CO2 into the atmosphere increases the amount of trapped heat, causing the Earth's surface to warm. One major consequence of warming temperatures is associated global sea level rise. As water heats up, it expands, leading to warmer oceans that occupy more space. In addition, most glaciers and ice caps across the globe are melting as air temperatures increase, contributing meltwater to the oceans. These two processes are responsible for most of the sea level rise we've experienced so far. However, ice mass loss from continental ice sheets, Greenland and Antarctica, is expected to dominate sea level rise in the near future. These ice sheets are susceptible to warming ocean and air temperatures and may become destabilized, contributing huge amounts of water to the world's oceans. Rising sea level has immediate consequences for coastal cities and low-lying countries. By the end of the century, almost 80 million people worldwide could be displaced. As sea level rises and temperatures increase, extreme events will occur with greater frequency and higher intensity. Like most coastal cities across the world, the city of Boston will face serious threat of inundation and associated flooding and infrastructure challenges. Boston will experience even higher sea level rise than the global average due to the gravitational influence that ice sheets exert on the world's oceans. Let's look into the different scenarios that Boston may experience throughout this century. Much of the uncertainty surrounding sea level prediction originates from political uncertainty. How will global populations evolve and land use change? How will different countries act to curb greenhouse gas emissions in the future, and when? What technologies will emerge, and what energy sources will humans rely on in the future? Representative concentration pathways, or RCPs, display possible trajectories of CO2 emissions projected into the future under an array of possible political, social, and environmental outcomes. RCP 2.6 is the most ambitious scenario, where CO2 emissions start to decline in 2020 and become negative by 2100. If global CO2 emissions follow this pathway in the future, we can expect an increase of 1.5 degrees Celsius by 2100. RCP 4.5 predicts a peak in global emissions at 2040, with increasing dependence on energy sources such as solar, bioenergy, nuclear, and natural gas. In this scenario, global temperatures will rise 2.4 degrees Celsius by the end of the century. RCP 8.5 is the business-as-usual scenario, where greenhouse gas emissions continue to skyrocket higher and higher. Most of the energy production in this scenario comes from coal, leading to massive increases in atmospheric CO2 concentrations and resulting in a temperature increase of 4.9 degrees Celsius by the year 2100. So, which scenario should we expect? The RCP 2.6 scenario entails negative CO2 emissions by 2100, requiring carbon sequestration. However, there are currently no technologies under development that could be deployed reliably at a large scale to remove carbon from the atmosphere in the foreseeable future. We have likely already exceeded the conditions of this scenario. So far, global CO2 emissions have tracked the RCP 8.5 pathway with no signs of slowing. Different RCP scenarios have different implications for the city of Boston. A team of Massachusetts scientists, commissioned by the mayor of Boston, have prepared a report predicting sea level rise under each scenario. Here we peek into the future of three notable Boston neighborhoods and landmarks: the Fenway Park baseball field, Faneuil Hall Marketplace in downtown Boston, and the view from Back Bay. For each RCP scenario, CO2 emissions rise, atmospheric CO2 concentrations increase, Antarctica and other sources of land-based ice contribute to global sea level rise, and we show how these factors affect Boston's shoreline. Under the most conservative RCP 2.6 scenario, sea level would increase by almost 3 feet by 2100 along the Boston coastline. As you can see, this effect doesn't have a huge impact at our 3 Boston locations or change the shoreline much. However, by 2200, we can expect an increase of almost 6.5 feet, even if we manage to follow this scenario and severely curb emissions. The RCP 4.5 scenario predicts slightly greater inundation by 2100 to over 3.5 feet. By 2200, the ocean could rise by 11 feet. Under RCP 8.5, the business as usual scenario, sea level along the Boston coastline reaches 5 feet by 2100. By 2200, sea level could increase by 26 feet, drastically altering Boston's shorelines. Even though most predictions are focused on what will occur this century, sea level rise will not halt at the year 2100. CO2 has a very long residence time in the atmosphere. Some molecules are removed by carbon sinks, such as the ocean, but as time passes, the rate of uptake slows. Even after 1,000 years, almost 1/5 of the original CO2 molecules remain. The greenhouse gases that we are accumulating in the atmosphere today will contribute to warming far into the future. Therefore, our actions right now have long-lasting impacts. For example, if we follow the RCP 8.5 pathway during this century, warming oceans will likely push the Antarctic ice sheet past a threshold of stability. This will commit ourselves to catastrophic and irreversible sea level rise during subsequent centuries, regardless of later CO2 emissions. A business-as-usual approach would lead to the complete inundation of the city of Boston by the year 2500. Sea level rise is only one facet of a rapidly changing climate. Changes in precipitation patterns and temperature fluctuations will also begin to affect agriculture, snowfall, and even mortality rates due to heat. For example, under the RCP 8.5 scenario, maximum temperatures across all seasons are predicted to increase by 5.8 degrees Fahrenheit by the end of the century. The city of Boston will need to build barriers and other defenses against the rising seas, revise building codes, and find other ways to adapt to changing climate and sea level. In addition to resiliency, Boston and the state of Massachusetts should also pursue CO2 emission reduction measures to avert complete inundation of Boston under the business-as-usual RCP 8.5 emissions pathway.